welcome back to the channel. This video is a consolidation of prime factors. So pause the video and have a go with the first two questions as a warm-up. Okay, so here we go. Question 1, we can see if it's correct, explain incorrect, explain why. Now the first bit is correct, they are co-prime numbers. Question 2, write as a product of primes. Now you may have spotted the error here, which is that 9. That is not a prime number. So this is false. We would correct this by writing 9 as 3 times 3 times 2 times 2. And then you can just tidy that up by writing it in order if you want to. So that would be 2 squared times 3 squared. That should be the correct answer. Okay, here is a practice exercise for you to try to express the following numbers as product of primes. Pause the video and the answers will appear in a few seconds. Okay, here come the answers in 3, 2, 1. These are all the answers to the questions. Check you have got this correct. You are allowed to show these in shorthand form. So for example, if you wrote 2 squared times 5, that's fine as well. For example, this thing here would be 3 times 5 squared, and so on. Okay. Recap. Use the prime factors to find all the factors of 28. So the first thing you do is once you've written the number as a product of primes, you can now use these to work out all the factors of 28. So a factor of 28 might be 2. We've already got 2 there, so you don't need to list it again. And then we've got 7. So in each of these cases, I've just used one of these numbers. Now I'm going to use 2 numbers at a time. So I could do 2 times 7, but I could also do 2 times 2. So 2 times 2 is 4. 2 times 7 is 14. So I've used 2 numbers in that case. And then I could use all 3 numbers, which is 2 times 2 times 7. That's going to give me 28. So here are all the factors. Now we just need to remember there's one missing that we need to always put down as a factor, which you won't find through this method, and that is the 1. Don't forget the 1. So we just need to make an actual list here. 1, 2, 4, 7, 14, 28. Now this method, you may not need it for such a small number like 28, but it becomes useful when you look at much bigger numbers. So here are some practice questions for you to try using that method. So write them as a product of primes. So I'll just give you a clue with 12. It's going to be 2 times 2 times 3. And then just using one of those numbers, what factors can you say? Well, it's going to be 2 and 3. Using 2 numbers, you could go 2 times 2, 2 times 3, and then using 3 numbers is 2 times 2 times 3. Okay, so pause the video and have a go with some of these. I'm now going to show you the answers here, so check these carefully. Just in case you're struggling to track the answers, this tells you how many factors you should have for each. Don't forget that 1 must be included for all of the answers. Okay, true or false? Let's assume that this statement up here is true. So this is your number that's been given as a product of primes. And we're going to use that to decide whether the following is true. 11 is a factor of the original number. Well, we can see that 11 is a factor, so that's true. Have a look at the next 2 statements. Okay, so 9 is a factor. Well, I can see 3 times 3 is 9, so 9 times the rest of the numbers will give me that. So yes, this is true. And then 27, can you make 27 using these prime numbers? We cannot make that, so that's going to be false. Try the next 2 questions. 15 is a factor. Well, we can make 15 because it's 3 times 5. So that's true. 8 is a factor. This is false because we can't make 8 with any of these numbers. 17325 is a square number. Now remember, a square number has got all factors are repeated. So we've got repeated factor, repeated factor. These are not repeated, so it's not a square number. An example of what would need to be true if it was a square number is, for example, if that was a 7, then that would be true because it would be 3 times 3, 3 times 5 times 7 times 3 times 5 times 7. You could rewrite this as a same number multiplied by itself. So that doesn't work, however, in this case. And then we've got the last two to try. If you multiply this number by 7, does it become a square number? Well, it doesn't, because there's still an 11 there that's not repeated. If you multiply it by 77, is it a square number? Well, 77 is 7 times 11. So in that case, we do have all factors repeated. So this would be true, and the one before it would be false. Okay, have a think about which of these pairs is an odd one out. When you spot it, unpause the video. Okay, I'm going to show you the answer now. You may have noticed that these are coprime except for 5 and 15, which share a common factor of 5. Find the highest common factor of HCF. Find the highest common factor of 45 and 27. So let's start reviewing this as an example. We can't divide it by 2, but we can divide it by 3. So it's going to be 15. 27 divided by 3 is 9. We can then divide these by 3 again. So 3 times 5 is 15, and 3 times 3 is 9. We stop here because they are coprime. And the highest common factor will be 3 times 3. Is 9. Okay, now if you have algebra involved, you need to be careful. Do the numbers first and then the letters, but if you're confident you can do it in one go. So I'm going to divide by 30 first. So that's going to be 2x and x squared y. Now 2 and 1, there's an invisible 1 there. They're coprime, so I ignore the numbers and I can look at x and x squared y. So I'm going to take x out, so this becomes 2. This becomes xy. We can write a 1 if we want to at the front. These are coprime. So the highest common factor is 30 times x, which is 30x. Okay, pause the video and have a go with all of these questions, and then I'm going to show you the answers in a few seconds. All right, here are the answers. Check your work. Okay, here is your final question to try. Have these been worked out correctly? Okay, so question 1, we can see we're taking m out, that's fine. Taking 2 out, that all seems fine so far. And then these are coprime, so yeah, m times 2, which is 2m, is correct. The one on the right, we have taken 2 out to be left with m and 30m squared. Now these are not coprime because we can still take out a factor of m to get 1 and 30m. So in this case, the highest common factor would be 2m. Okay, hope that was useful. See you in the next video.